The water was freezing his fingers through the gloves, but Mikhail Karbyshev kept his hands on the rope anyway, checking tension one more time before the first tank attempted the crossing. 20 centimeters below the Dnieper's surface, invisible from the air, invisible from the western bank where German reconnaissance was probably watching through binoculars right now, lay a bridge that Soviet engineering regulations classified as structurally impossible. He had 6 hours to prove that physics didn't care about regulations. 6 hours before 15,000 men would be trapped against this river with nowhere to run. The timber posts were vibrating under his touch. Not from current, not from wind. From the weight of 42 artillery pieces lined up on the eastern bank, waiting their turn to cross something that wasn't supposed to exist. The bridge couldn't be seen, couldn't be photographed, would vanish without trace the moment the last man crossed. But it would work. Had to work. Because mathematics didn't lie, and Karbyshev had done the calculations 300 times over the past 2 years, ever since the Academy Review Board had laughed at his thesis and called underwater bridges a fantasy. Captain Mikhail Karbyshev, 47 years old, bridge engineer, had built structures across a dozen Russian rivers during his career, knew everything about load-bearing calculations and stress tolerances and foundation stability in moving water, could calculate spans and supports in his head faster than most officers could read the numbers off a page. And 2 years ago, he had proposed a technique that violated every regulation in the Red Army engineering manual, a technique his professors had mocked as impossible, a technique that was now the only thing standing between 15,000 Soviet soldiers and German encirclement. The eastern bank was chaos, refugees clogging the single conventional bridge that crossed the Dnieper, a kilometer south. Women pushing handcarts loaded with everything they owned, old men carrying children on their backs. The mathematics were brutal and simple. 300 people per hour could cross that bridge. 15,000 soldiers needed to cross. 50 hours required. And German panzers were 8 hours away, maybe 10 if the reconnaissance reports were wrong, which they never were. 14,000 men would die if he couldn't make this work. 14,000 men would be captured, sent to camps, lost forever because there wasn't enough time and there wasn't enough bridge. Unless the band technique worked. Unless 20 centimeters of water could hide a structure strong enough to carry tanks. Unless physics really was smarter than Soviet doctrine. His construction battalion was watching him from the riverbank. 50 men, exhausted from 6 hours of underwater carpentry, hands raw from handling timber in freezing current, faces showing the particular expression soldiers get when they realize their commanding officer might be insane. Sergeant Petrov approached carefully, the way you approach someone who might explode. "Sir," Petrov said quietly, "the first tank commander is asking about navigation markers. He can't see the bridge surface underwater. Wants to know how he's supposed to stay on the planks without driving into the river." Karbyshev had expected this question, had prepared for it during the long nights after his thesis was rejected, when he'd stayed awake calculating solutions to problems that officers said didn't exist because the bridge itself didn't exist. "Ropes," he said. "Submerged ropes along both edges of the bridge deck. The driver keeps his left tread between the ropes. Tank width is 3 meters. Bridge width is 4 meters. 1 meter clearance on each side. Physics doesn't require vision. Just mathematics." Petrov stared at him. "Sir, with respect, you're asking a tank driver to navigate blind across an invisible bridge submerged in a river, while German artillery might start ranging this position at any moment." "Yes," Karbyshev said, "that's exactly what I'm asking, because the alternative is 14,000 men die. So we're doing it anyway." This is the story of the banned bridge, the underwater structure that Soviet regulations said couldn't exist and German pilots couldn't see. The illegal engineering trick that saved an army. and the captain who broke every rule because physics doesn't care about doctrine, only about mathematics and the courage to test them. Let's pause here for a moment. If you find value in stories like this, you can support the channel by liking the video and subscribing. After watching, leaving a brief comment, even a simple word, helps more than you might expect. Your support keeps these stories alive and visible. Thank you. Let's move on. September 1939. 2 years before the Dnieper crossing. 2 years before Karbyshev would build the impossible bridge under combat conditions. Leningrad Engineering Academy. A lecture hall packed with senior engineers and military officers, all waiting to evaluate thesis presentations from the academy's top students. Karbyshev stood at the podium with a wooden model in his hands, a miniature bridge submerged in a glass tank filled with water, and he was about to propose something that would get him laughed out of the room. Alternative bridge construction techniques for rapid deployment in combat conditions, he began, reading from his prepared text. Conventional doctrine requires bridges to be built above water level, with clearance for navigation and visibility for crossing forces. I propose an alternative. Build the bridge underwater, 20 to 30 centimeters below the surface, invisible to air reconnaissance, immune to strategic bombing, constructed rapidly with minimal materials. The room went very quiet. Not the good kind of quiet where people are thinking seriously about a new idea. The bad kind of quiet where everyone has simultaneously decided you're an idiot, but nobody wants to be the first to say it out loud. Professor Viktor Sokolov stood up. Head of the engineering department, 60 years old, had built bridges across half of Russia during the Civil War. His face was already turning red before he started speaking. "This is not engineering," Sokolov said, his voice cutting across the lecture hall with the precision of a man who had spent decades crushing stupid ideas before they could waste anyone's time. "This is fantasy. Water pressure creates lateral stress that timber cannot support at depth. Vehicle navigation would be impossible. Drivers cannot see the bridge surface underwater. They would drive off the edges, drown their vehicles, block the crossing for everyone behind them. This concept violates fundamental principles of load distribution and structural stability." Karbyshev tried to interrupt. "Comrade Professor, the water pressure at 20 centimeters depth is only 2 kilopascals. Standard timber can support hundreds of kilopascals. The stress calculations are irrelevant," Sokolov shouted, and now other officers were standing up, joining the attack. Because once a thesis presentation turns into a public execution, everyone wants to participate. A colonel from the engineering corps stepped forward. "Even if the structure somehow held, which I seriously doubt, the tactical problems are insurmountable," the colonel said. "How do drivers navigate blind? How do you mark the bridge edges underwater without making them visible to air reconnaissance? How do you prevent vehicles from sliding sideways off wet planks? One tank loses traction and drives into the river, and the entire crossing fails. Vehicles back up behind it. The bridge becomes a death trap instead of an escape route." Another officer joined in. "Water resistance would slow vehicles to a crawl. A tank moving through 20 centimeters of water experiences drag force equivalent to moving through mud. Crossing time would triple compared to a conventional bridge. You'd create a traffic jam underwater. Vehicles would stall. Engines would flood. The entire concept is operationally nonsensical." Karbyshev stood at the podium, watching his thesis die in real time. Watching 2 years of calculations and model testing get dismissed in 5 minutes by men who hadn't done any mathematics, but who knew, absolutely knew, that underwater bridges were impossible. He tried one more time. "The model works," he said, pointing to the glass tank where his miniature bridge sat 20 centimeters below the water surface, supporting a model vehicle that was clearly not sinking. "The physics are sound. The calculations prove it's feasible. I'm not proposing this for routine use. Only for emergency tactical situations where conventional bridging is impossible or too vulnerable to air attack. Sokolov walked up to the tank and knocked the model vehicle off the bridge with one finger. It sank to the bottom of the tank. "Your model is a toy," he said. "Physics at scale are different. Water pressure compounds. Structural stress multiplies. A real bridge supporting real tanks would collapse immediately. This thesis demonstrates a fundamental misunderstanding of engineering principles. I recommend rejection." The vote was unanimous. Thesis rejected. Concept classified as structurally unsound. Engineering regulation. 43 amended to explicitly ban underwater bridge construction as tactically dangerous and operationally impossible. Karbyshev left the academy that day with a rejected thesis and a growing suspicion that the regulation was wrong. That the mathematics were right, but the doctrine was stupid. That underwater bridges could work if anyone had the courage to try building one under real conditions instead of dismissing the concept because it seemed impossible. He kept his calculations, kept his models, kept doing the mathematics in his spare time, refining the design, working out solutions to the navigation problem and the water resistance problem and the structural stability problem. Because someday, he thought, someday there might be a situation desperate enough that banned engineering would be the only engineering that could work. October 19th, 1941. That someday arrived. Karbyshev stood on the eastern bank of the Dnieper at 3 a.m, watching his army drown in German encirclement. 15,000 men trapped on the western bank. 23 tanks running low on fuel. 42 artillery pieces that would have to be spiked and abandoned because there was no way to cross them over the single conventional bridge that was already clogged with refugees. German reconnaissance had been spotted 5 kilometers west. Panzer divisions following. The mathematics were brutal. 8 hours until encirclement closed. 50 hours needed to evacuate everyone across the conventional bridge. 42 hours short. 14,000 men who would die or be captured because there wasn't enough bridge. Unless he built the banned bridge. Unless he violated Regulation 43 and constructed the underwater structure that Soviet doctrine said was impossible. Unless he was willing to face court-martial for trying something forbidden. Karbyshev turned to his construction battalion, 50 men who had been building conventional bridges across Russian rivers for the past 2 years, and who were about to discover that their commanding officer had gone completely insane. "We're building an underwater bridge," he said, 20 centimeters below the surface, 4 meters wide, 80 meters long. We have 6 hours before the panzers arrive. Get the timber from the supply depot, all of it, every post and plank we have. We're not building this by regulation, we're building it by mathematics." The men stared at him. Sergeant Petrov spoke first, his voice very careful. "Sir, underwater bridges are banned. Engineering Regulation 43. Structurally unsound, tactically dangerous. We could be court-martialed for attempting this." "Yes," Karbyshev said. "We could be court-martialed. We probably will be court-martialed. But if we don't build this bridge, 14,000 men die. So we're building it anyway. Now move!" The construction began at 03:47 a.m. 50 men working in freezing water, driving timber posts into the riverbed, laying planks across supports, creating a structure that couldn't be seen from above, and that Soviet doctrine said couldn't exist. Karbyshev worked alongside them, waist-deep in the Dnieper, checking stress calculations in his head while his hands checked post alignment by feel in the darkness. The first posts went in wrong. Too shallow. The riverbed was softer than his reconnaissance had suggested, probably from recent flooding, and the posts weren't finding solid purchase. They'd sink under vehicle weight, shift laterally under current pressure, collapse the entire structure before the first tank made it halfway across. Karbyshev had his men pull them out and drive them deeper, an extra 40 centimeters into the mud, compensating for soil density he couldn't see and couldn't measure, but could only estimate based on how the timber felt when it finally stopped sinking. This was the problem with banned techniques. No established procedures, no field manual to reference, no generations of engineers who had solved these problems before and written down the solutions. Just Karbyshev and his calculations and the growing certainty that if he got the mathematics wrong, 13,000 men would drown in this river or die in German camps because his bridge had failed. The water temperature was 4 degrees Celsius, cold enough that his men were developing hypothermia after 20 minutes of immersion, hands going numb, movements becoming clumsy and slow. He rotated them in shifts. 10 men in the water at a time, working for 20 minutes, then 10 minutes on shore warming by fires that they couldn't make too large because German reconnaissance might spot the smoke. Inefficient. Slow. But the only way to keep everyone functional and prevent casualties from exposure before the bridge was even finished. The timber came from the supply depot 3 kilometers east. Standard bridge construction material. Pine posts 30 centimeters in diameter. Oak planks 10 centimeters thick. Nothing exotic. Nothing special. Just regular engineering supplies that Soviet doctrine said couldn't be used for underwater construction because the stress calculations didn't work and the physics were impossible. Karbyshev was using them anyway because his calculations said doctrine was wrong and physics worked fine if you understood the actual forces involved. Each post needed to be positioned exactly 3 meters from the next post. Too close, and they'd interfere with each other's load distribution, create stress points where the structure would flex and fail. Too far apart and the planks wouldn't have adequate support, would bend under vehicle weight, crack and collapse. 3 meters. Exactly. Measured by rope in darkness while standing waist-deep in freezing water with German reconnaissance somewhere 5 kilometers west and closing. The planks went across the posts in overlapping layers. First layer running parallel to the current, distributing vehicle weight across multiple support points. Second layer running perpendicular, preventing lateral shift when tanks turned or adjusted position. Third layer parallel again, providing the actual driving surface where treads would grip. 3 layers total. 40 centimeters of timber creating a deck that would sit 20 centimeters below the water surface when the weight of the structure settled into the riverbed. By 05 a.m., they had completed 20 meters. 1/4 of the bridge finished. The men were exhausted beyond exhaustion, moving like automatons, following orders without question because thinking required energy they didn't have. Karbyshev himself was hypothermic, his teeth chattering so hard he had to clench his jaw to speak clearly when giving instructions. The fires on shore looked impossibly distant and warm. The work looked impossibly incomplete. 20 meters done, 60 meters remaining, and German panzers were now 4 hours away instead of 8 because they'd been moving faster than expected during the night. Sergeant Petrov emerged from the water shaking uncontrollably, hands blue-white from cold. "Sir," he said through chattering teeth, "at this rate we'll need another 6 hours to complete the bridge. The Germans will be here in 4. The mathematics don't work." Karbyshev knew Petrov was right. The mathematics didn't work. Not at current construction rates. He had assumed warmer water, softer riverbed, faster post placement. Had calculated 6 hours total construction time based on assumptions that were proving wrong in practice. The actual conditions were different, and the timeline was collapsing and 14,000 men were about to die because Karbyshev had made errors in his initial estimates. He could stop now. Could tell his men to abandon the construction, evacuate across the conventional bridge even though it meant leaving most of the army behind. Could report to headquarters that the underwater bridge attempt had failed, that doctrine had been correct, that banned techniques were banned for good reason. Could save himself from court-martial and his men from dying of hypothermia in a river while building something impossible. Or he could adapt. Could change the design mid-construction. Could violate even more regulations by building a partial bridge, incomplete structure that would save some men even if it couldn't save everyone. Could trust mathematics one more time and hope that physics would forgive approximation when necessity demanded it. "We're changing the design," Karbyshev said. "The bridge only needs to be 60 meters long, not 80. We'll start the crossing point 10 meters east of my original plan. Shorter span means less construction time. We finish in 4 hours instead of 6. Some artillery pieces will have to ford the eastern approach, but tanks can make it, and that's what matters." Petrov stared at him. "Sir, a 60-meter bridge won't reach the western bank. Vehicles will have to drive through 3 meters of water to reach it. Some will stall. Some will flood their engines. We'll lose vehicles in the approach." "Yes," Karbyshev said, "we'll lose some vehicles, but we'll save most of the army. Now get the men back in the water. We're building 60 meters of bridge, and we're doing it in 4 hours because that's all the time we have." The mathematics were working. The posts were holding. The planks weren't shifting. Water pressure at this depth was exactly what his calculations had predicted. 2 kilopascals. Nothing. The real stress was from timber weight and current drag, and the structure was handling both without problem, proving that Soviet doctrine had been wrong about underwater bridges, and Karbyshev had been right about physics not caring what regulations said about impossibility. By 06:00 a.m., the bridge was half complete. 40 meters of underwater structure extending from the eastern bank toward the western shore. The men were exhausted, hypothermic, moving like machines because stopping would mean dying from exposure. Karbyshev kept pushing them forward because German reconnaissance was getting closer, and there was no time for rest. By 08:30 a.m., the bridge was done. 80 meters of submerged timber connecting both banks of the Dnieper, invisible from the air, marked only by ropes running along the edges to guide vehicles across the hidden deck. Karbyshev tested it himself first, walking across planks he couldn't see, feeling with his feet for the edges, using the guide ropes to maintain direction. The structure held. Didn't shift. Didn't collapse. Physics was working exactly as mathematics had predicted. Now came the real test. A T-34 tank weighing 26 tons needed to cross something it couldn't see. The driver, a young lieutenant named Volkov, climbed into the tank looking like a man who had just been ordered to commit suicide. "Keep your left tread between the guide ropes," Karbyshev told him. "The bridge is 4 meters wide. Your tank is 3 meters wide. You have half a meter clearance on each side. Drive slowly. Feel for the planks. The structure will hold. I promise you the structure will hold." Volkov didn't look convinced. "Sir, I can't see anything underwater. How do I know I'm still on the bridge and not about to drive into the river?" "You trust the mathematics," Karbyshev said. "I spent 2 years calculating this design. The bridge will support your weight. The guide ropes will keep you centered. You just have to trust the physics and drive." The T-34 entered the water at 09:15 a.m. Volkov driving at walking speed, the tank's engine roaring against water resistance, its treads churning white foam as they found purchase on the submerged planks. Karbyshev watched from the eastern bank, counting seconds, waiting for the moment when physics would either prove him right or kill everyone who tried to cross this bridge. The tank didn't sink, didn't slide off the bridge, didn't collapse the structure. It moved across the Dnieper like some impossible machine defying gravity and common sense, treads gripping planks that nobody could see, creating a rooster tail of spray that made it look like the tank was driving on top of the water instead of on a bridge 20 centimeters below the surface. 90 seconds later, the T-34 reached the western bank and climbed out of the river without incident. Volkov opened the hatch looking shocked that he was still alive. Karbyshev felt a moment of vindication so powerful it almost made up for 2 years of mockery and regulations calling him an idiot. The rest of the army started crossing, tank after tank driving into the Dnieper and crossing on a bridge they couldn't see. Artillery pieces pulled by trucks, crews holding guide ropes to stay centered on the submerged deck. infantry wading across in groups of 50, using the bridge as a ford, walking on planks while water came up to their waists. The evacuation that was supposed to take 50 hours was happening in 6 hours because physics didn't care about regulations and banned techniques worked if you understood the mathematics. German pilots flew over the crossing at 11 a.m., reconnaissance aircraft circling above the Dnieper, cameras recording Soviet forces crossing the river with no visible bridge. The intelligence reports must have been fascinating. Tanks driving through water, artillery crossing streams with no observable support structure, troops walking on the surface of the river like some miracle from religious text. The Germans bombed the conventional bridge a kilometer south, hit it with precision strikes, destroyed it completely, killed hundreds of refugees who were still trying to cross. But they couldn't bomb what they couldn't see. The underwater bridge was invisible from altitude, immune to strategic bombing, exactly as Karbyshev's rejected thesis had predicted. By 14 hours, 13,000 men had crossed the Dnieper using the banned bridge. 23 tanks, 38 artillery pieces. 4 were left behind because their crews panicked and tried to cross the conventional bridge instead, got caught in the German bombing, lost their vehicles and their lives. But 13,000 men lived because underwater engineering worked exactly as banned regulations said it couldn't. The last soldier crossed at 14:47 hours. Karbyshev himself crossed last, walking on planks he couldn't see one final time, feeling the structure hold beneath his feet, carrying the weight of his decision to violate regulations and trust mathematics instead of doctrine. When he reached the western bank, he turned and looked back at the Dnieper, at the water that showed no evidence of the bridge hidden beneath its surface, at the structure that had saved an army and that would vanish without trace the moment the current shifted the timbers. Then he was arrested. Military police waiting on the western bank. Orders from Divisional Command. Captain Mikhail Karbyshev charged with violation of Engineering Regulation 43, unauthorized construction of banned bridge type. Court-martial scheduled for October 25, 1941. Sergeant Petrov tried to argue. "Sir, he saved 13,000 men. The bridge worked perfectly. How can they court-martial him for saving an army?" The military police officer looked tired. "Because he violated regulations. Because underwater bridges are banned. Because the Red Army doesn't allow officers to ignore doctrine, even if ignoring doctrine saves lives. He knew the regulation. Built the bridge anyway. Now he faces the consequences." Karbyshev said nothing during the arrest, said nothing during transport to divisional headquarters, said nothing when they locked him in a holding cell to await trial. He had known this would happen, had accepted court-martial as the price for trying banned engineering, had decided that 13,000 lives mattered more than his career or his freedom. But he had also done the mathematics on regulations versus results, and he suspected the Red Army would have difficulty executing an officer who had just prevented the loss of an entire division. The court-martial hearing occurred 6 days later. A panel of 3 senior officers, all engineers, all familiar with Regulation 43, and all aware that Karbyshev had violated it deliberately. The proceedings were formal, precise, potentially fatal. "Captain Karbyshev," the presiding officer began, "you are charged with violation of Engineering Regulation 43, which explicitly bans the construction of underwater bridges on grounds of structural unsoundness and tactical danger. How do you plead?" "Guilty," Karbyshev said. "I built an underwater bridge. I knew it violated regulations. I did it anyway." The officer looked at him for a long moment. "Why?" "Because 15,000 men were about to die, and the mathematics said the bridge would work. I trusted physics over doctrine. The bridge held. 13,000 men evacuated safely. I would make the same decision again." The panel deliberated for 40 minutes. Karbyshev waited in the holding cell, mentally preparing for either execution or the gulag, running calculations in his head to distract himself from the possibility that saving 13,000 lives might still result in his death for breaking regulations. The panel returned with their verdict. Not guilty. Charges dismissed, with commendation for exceptional engineering under combat conditions and for saving divisional forces from encirclement and destruction. The presiding officer explained. The regulation exists to prevent structural failures that could kill troops attempting to cross unstable bridges. But your bridge didn't fail. Your calculations were correct. Your construction was sound. 13,000 men are alive because you understood physics better than regulations understood physics. The Red Army values results over doctrine when results save armies. You're dismissed, Captain, and congratulations. Karbyshev left the courtroom in a state of shock bordering on disbelief. Petrov was waiting outside. "Sir," Petrov asked, "what happened?" "Charges dismissed. We're not going to the Gulag." Petrov's face showed the same shock Karbyshev felt. "They commended you for building a banned bridge?" "They commended me for saving 13,000 men. The bridge was just the method. Sometimes results matter more than regulations. Sometimes you have to break rules to do what's right. And sometimes, if you're very lucky, the people judging you understand that." There was more. The review board studied Karbyshev's original academy thesis, read his calculations, tested his designs with full-scale models. In December 1941, they issued a new regulation. Engineering Regulation 43 revised. Underwater bridge construction is authorized for emergency tactical situations. Depth 20 to 30 centimeters below surface. Structure timber posts with plank decking. Maximum span 80 meters. Load capacity confirmed for vehicles up to 30 tons. The banned bridge had become official doctrine. The illegal trick had become standard practice. And Karbyshev's court-martial had turned into commendation and vindication of everything he had calculated 2 years earlier when professors mocked him for proposing the impossible. The technique spread. Other Soviet engineers learned about underwater bridges, studied the designs, built their own structures across rivers where conventional bridging was impossible or too vulnerable to air attack. The Germans never understood what was happening, never discovered the secret, kept filing intelligence reports about Soviet forces crossing rivers with no visible bridges and tanks driving through water like magic. January 1942. The Volga River. Soviet forces trapped by German encirclement, needing to evacuate across ice-choked water where conventional bridging was impossible because the ice was too thin to support weight, but too thick to break through for boats. The mathematics said evacuation was impossible. But Major Vladimir Sokolov, son of the professor who had mocked Karbyshev's thesis, remembered the underwater bridge technique, adapted it, built the bridge deeper, 40 centimeters below surface, underneath the ice layer, created a passage beneath the ice where troops could wade across with water to their chests. Freezing. Brutal, but alive. 4,000 men saved using banned engineering that was no longer banned, built by the son of the man who had called it impossible. March 1942, the Don River. German bombers destroying every conventional bridge, making it impossible to move artillery across in daylight. But Captain Alexei Petrov, the same sergeant who had questioned Karbyshev at the Dnieper, built an underwater bridge 25 centimeters below surface, marked the edges with submerged ropes, and troops walked across in darkness pulling artillery pieces through water invisible to German aircraft overhead. The technique became known as the Ghost Bridge among Soviet forces. Bridges that couldn't be seen, that appeared impossible, that defied German intelligence and enabled tactical withdrawals that conventional engineering said couldn't happen. Hundreds were built during the war, saving countless lives, proving that banned techniques could work if you understood the physics and had the courage to try them. German commanders never solved the mystery. Their intelligence reports documented Soviet forces crossing rivers without visible bridges, tanks driving through water without support structures, artillery crossing streams with no observable engineering. It seemed like some trick of physics that German doctrine hadn't considered, which was exactly true. Soviet engineering, desperate and innovative under combat conditions, had discovered that banned techniques could work, that regulations written in peacetime didn't account for wartime necessity, that sometimes the illegal solution was the only solution, and physics didn't care whether doctrine approved or not. After the war, the technique was studied by Western military engineers. NATO forces tested underwater bridges, found they worked exactly as Soviet calculations had predicted, incorporated the technique into field engineering manuals. The banned bridge became international doctrine, taught at military academies worldwide, standard practice for rapid river crossings under combat conditions. But they never gave credit to Karbyshev, never acknowledged the Soviet engineer who had proposed the technique in 1939 and been laughed at, who had built the first operational underwater bridge in 1941 while facing court-martial, who had proved that physics was smarter than regulations and that courage to test banned ideas could save armies. Mikhail Karbyshev continued serving in the Red Army after the Dnieper crossing, rose to the rank of colonel, built dozens more bridges, conventional and unconventional, saved countless lives through creative engineering and willingness to try solutions that doctrine said were impossible. Was captured by Germans in 1944 during the retreat from Belarus. Died in Mauthausen concentration camp in February 1945, executed for refusing to cooperate with German engineering projects and for maintaining his loyalty to Soviet forces despite torture and starvation. His underwater bridge technique survived him, was used in Korea when United Nations forces needed to cross rivers under air attack. In Vietnam, when Viet Cong forces built invisible bridges that American bombers couldn't target. In the Middle East, wherever military forces needed to cross water quickly and invisibly. The banned technique had become universal practice, the illegal trick had become standard engineering, and the captain who broke regulations to save an army had become a footnote in military history. After the war, military engineering academies studied the Dnieper crossing as a case study, teaching future engineers that sometimes banned techniques work, that regulations are guidelines, not laws of physics, that desperation breeds innovation, that one man's courage to try something forbidden can save thousands of lives and change doctrine forever. Professor Viktor Sokolov, who had mocked Karbyshev's thesis in 1939 and called underwater bridges a fantasy, was interviewed in 1956 about the technique. Asked about his rejection of the concept, about his claim that underwater bridges were structurally impossible and tactically dangerous. "I was wrong," Sokolov said, his voice carrying the weight of 17 years of knowing he had been wrong about something important. "I applied peacetime thinking to wartime problems. I assumed that because something violated established doctrine, it couldn't work. I didn't test it properly, didn't consider that desperation might make the impossible possible. Karbyshev understood something I didn't. He understood that physics doesn't care about regulations, that if the mathematics work, the structure will work, regardless of what doctrine says about it. I mocked him at the academy. I voted to reject his thesis. I called him an idiot who didn't understand real engineering, and I was completely wrong." Karbyshev's original academy thesis was republished in 1960, 15 years after his death in Mauthausen. Became required reading for Soviet engineering students, the paper that had been rejected now canonical, the concept that had been banned now foundation of a technique used worldwide by military forces who needed to cross water invisibly. But the man himself was nearly forgotten. His name appeared in a few military records, some engineering journals, a brief mention in books about Soviet military innovation. But no monuments, no public recognition, No acknowledgement that the ghost bridge technique used across 3 wars and 4 decades had originated with a captain who broke regulations because 13,000 lives mattered more than his career. The underwater bridge at the Dnieper was never photographed, never documented visually. It existed for 6 hours on October 19, 1941. Saved 13,000 men. Then vanished beneath the water when current shifted the timbers and the structure broke apart. No physical evidence remained, just mathematical calculations in Karbyshev's notebook. After-action reports describing an impossible crossing. Testimony from survivors who walked across water and lived to tell about it. German pilot Hans Rudel, who had flown reconnaissance over the Dnieper crossing, wrote about it in his memoir published in 1952. Years later, I learned about Soviet underwater bridges, about their technique of building structures 20 centimeters below the surface, invisible from the air, immune to bombing. When I read about it, I finally understood what I had seen that day over the Dnieper. The impossible crossing. The troops walking on water. The tanks driving through the river without any visible support. It wasn't magic, it was engineering that our doctrine said was impossible, but which worked perfectly because physics doesn't read doctrines, it just follows mathematics. And the Soviets had understood the mathematics better than we did. That was the lesson. The hard lesson that cost lives and careers to learn. Physics doesn't care about regulations. Banned techniques sometimes work better than approved ones. Desperation and creativity can solve problems that conventional thinking cannot. And one man with calculations and courage can prove that impossible is just a word people use when they haven't done the mathematics properly. The banned bridge. The illegal trick. The underwater structure that saved an army and changed military engineering forever. Built by a captain who ignored regulations because 15,000 lives mattered more than doctrine, who faced court-martial and won, who proved that sometimes breaking the rules is the right thing to do, and sometimes physics is smarter than the people writing the regulations. That was Mikhail Karbyshev, the man who built bridges that weren't supposed to exist, who saved armies using techniques that were forbidden, who demonstrated that courage isn't just fighting, sometimes it's building, sometimes it's creating something banned because lives depend on it, and mathematics say it will work. The Soviet command ignored his warnings for 2 years, mocked his thesis, banned his technique, called it structurally unsound and tactically dangerous and operationally impossible. Then, when crisis came, when conventional engineering couldn't save the trapped army, when 14,000 men were about to die because there wasn't enough bridge, they discovered that the banned bridge worked perfectly, that underwater structures could support tanks, that invisible crossings could save armies, that Karbyshev had been right about the physics and the regulations had been wrong about the possibilities. 15,000 men walked across water on October 19, 1941. 23 tanks drove through the Dnieper on a bridge nobody could see. An army escaped encirclement that mathematics said was inescapable. All because one captain understood something the regulations didn't understand. That underwater bridges, built with proper physics and desperate courage and willingness to face court-martial for doing the right thing, could achieve what doctrine said was impossible. They mocked him in 1939. They banned his technique. They told him he didn't understand real engineering, that his calculations were fantasy, that underwater bridges violated fundamental principles of construction. And in 1941, they watched in shock as his illegal bridge saved an army, as physics proved stronger than regulations, as the impossible became real because mathematics don't lie and courage doesn't quit, and sometimes one man with a rejected thesis knows more about engineering than an entire academy of professors who never tested their assumptions. That was the trick. The banned trick. The underwater bridge that changed military engineering forever. Built in 6 hours. used for 6 hours, gone forever. But remembered by every engineer who learned that sometimes the rules are wrong. And sometimes, one man with calculations and courage can prove it, save an army, and change doctrine forever even if his name is forgotten, and his sacrifice is reduced to a footnote in the history of military innovation. The bridge that wasn't supposed to exist. Built by the captain who wouldn't accept impossible as an answer. That was Mikhail Karbyshev. That was the Ghost Bridge. That was the trick that saved 15,000 lives and proved that physics doesn't care about regulations, only about mathematics, and the courage to test them under conditions where failure means death and success means court-martial. And sometimes you have to choose between following rules and doing what's right.